Today we're doing part two. We're doing part two of, how do I say? We're doing part two of whiteboarding the forward pass of an LLM. Oh goodness. Um, we have Mike Guy to my left. Um, what's it called? I did some upgrades to the whiteboard app. So full screen is more native. Hopefully on YouTube. Also, just now I made it so like hopefully you can't see my hands right now, even though I can see them, is the videos are going to be cropped so that the aspect ratio is actually like the 16:9 that's native to YouTube. So hopefully we're a little bit more polished now. We got the phone camera, you know, and then the whiteboard. I'll show you the features that I added. They're small, but they're of substance. You know what I mean? Like we're actually like completely bordered. You know what I mean? There's no like rounded corners, and you can't see the. How do I say? You can't see this the mirror, exit the fact that I'm full screen, all that kind of stuff. And if you remember the last video, I complained, I wish I could expand from all four corners like any other normal window. All those little things are fixed now. So hopefully we have a great time. Images, what's it called? We didn't have images last time either. That's another cool thing. Is like I have a camera roll of awesome stuff. So now I can sort of like put those in the videos. I thought of Mike Guy because like, because just good energy, you know what I mean? He's like one of my favorite. This is one of my favorite positivity photos. So I figured we start with it. But there's like sort of like no context for you guys. Like, why is my guy there? It means something to me. That's why he's there. Um, so let's get started. I think I'll do a little bit of show and tell because how do I say? Check out the swap. So actually, I'll be going here, and then we have we're actually on the iPad. So what's it called? This is just first thing is zooming in and out. We have zooming in and out for like touch on my phone. I have, Apple Pencil from school and whatnot. Um, Drawing is nothing new. Selecting objects is new. So now I can, this isn't me panning, this is me selecting my guy. So let's do, what's it called? Let's do a star so you can sort of see the difference because you can't see there's like a dashed line thing for when I select objects. It's like, this is me moving just the star. This is me moving both of them. And then this is me zooming and panning, you know? Um, we have that. We have erasing. We should have had that before. That's fine. We can now do dashed lines. This is a bit inconsistent. I'd say that's good enough. We have dashed lines and we have dotted lines naturally. Nice. What's it called? When these were first built, the dotted lines were inconsistent. So I'm glad Claude fixed that in one try. Um, let's see. And then what else? Yes, images, library. Um, let's see. I don't know. I've got so many photos, dude. Let's see. Yeah, hell yeah, LeBron. Okay, this is crazy. So I'm having so much fun because I'm live streaming my iPad to my computer. I've never done this before. Um, yes, this is insanity. This might be the thumbnail. I don't know. I'm not sure. Um, ah, ah. Okay, whatever. That's like so cool, bro. That's like so much fun. Um, and like, yeah, I can do like sort of like pop culture things, but we're talking about LLMs. What does LeBron have to do? Oh my goodness, bro. If I could produce content on where it's like educational on LLMs, but for whatever reason it's tied to things that are fun, I think that'd be super cool. So I have full control over everything, zooming, and I can now save um my boards, whatever, like, wherever we left off from last video, I'll be able to come back to. I have a feeling that this whiteboard style I might make a standard because this is actually the original thing that we were doing before with the transformer of me drawing it on the whiteboard at my office building, except now you guys can actually see what's going on. I think the only difference is we're missing vault chat. We're missing how quickly I can ask David a question. Right now I would sort of like have to exit, open vault chat, paste like a screenshot of an image. I wonder how hard that would be. to get that included into this app. That's a question for later. Um, but that would be a sort of like nice to have like easy thing is if I don't know if you can imagine you can't see that. What's it called? If you imagine there's like an assistant here, like a little button, and then I talk to it or something. You know what I mean? Like maybe it's part of the voice app. Um, but yeah, so I maintained. We took a screenshot last time of what's it called? Of our board. So guess what? It's back. Oh, and then this also gives you a glimpse of the UI on my end. Is these this is my drawing board, but that's the old one, and I'll take a screenshot right now. This is so much fun. You can see the upgraded one. And oh yeah, this should be very, very brief moment. Let's see. There you go. So now we have, um, dashed lines, dotted lines on the left. We still have whatever, instead of words, it's symbols. I really don't like that the text box looking thing. This is I need to stop being in dashed. This is the lasso for selecting things. That's not has nothing to do with text. Images, undo, redo. Um, this is to go from light mode and dark mode, and then this is the files for save things. And these are both to let me know that I'm streaming to my computer. Cool, cool, cool. Um, we'll lasso this, and then yeah, how do we want to handle this original one? Is I guess I could sort of, yeah, I can sort of zoom in so much that we're just back where we left off. Bam. That's not bad. And where do I fit? Yeah, that's not horrible. Um, so yeah, let's see. So where we left off is we have text. We do our BPE. This gives us our vocab space. I was sort of talking to Claude yesterday, because I don't like tokens. They're a bit weird, Um, what's it called? I don't like the fact that I don't know that AN. No, that's actually a horrible example. Um, let's see. I don't like the fact that Xed. I don't like that Xed could be a token. You know what I mean? Because it's connected to X. It's because it's connected to text and a bunch of other stuff. But like X is a token in itself, but like X doesn't mean anything. Um, and what I was talking to Claude about is like, say for example, T is a token and X is the second token. The first transformer blocks are going to detokenize, I think is the word, and it's going to actually turn the fact that X and T are next to each other into a representation of the word text. And like, it's sort of like the staging thing is like, let's turn these tokens into substance. And then, but like, a bit of a weird thing that I don't have the answer for is like, what does that substance looks like? Are you going to give the embeddings that are at both of these indices the same embedding because they're now containing the same piece of information? Or are you going to give this one or this one? You're going to give one of them the correct one and you're going to like structurally ignore the other one. So like ext now is going to embed the information of text and say this is index 0 and this is index 1. We now basically consider it doesn't exist. All future transformations it's almost as if there's a mask for that token. I don't know. But then you also can't really do that in the weights. You would almost have to like 0 is a weird thing. Yeah, I don't know how you would have to I don't think you can do a mask. I don't think you can zero it out because if you can't, maybe you can. It's not coming immediately to me, how you can dampen a particular token on demand. That's how I would phrase it. Is like, does the model choose what tokens to even look at? Isn't that attention though? That's the whole point. Yeah, so you would change the attention for that token. Is now we focus on the EXT token and nobody is going to attend to T. And that attention is based off of the QKV of that token, which has been transformed by the previous transformers, and now it has been given a ignore me embedding representation. Yeah, we're getting a bit abstract there. So let's see. We have this could easily become part 3, but we're just getting started. So let's see. We have text, we have BPE, vocab. This gives us our data set. You know, again, I just started this video, so it's my turn to recall as well. Is we're gonna say a sentence is, let's say, the cat. Oh yeah, we can sort of represent it. I'm very scared. Two things. In the previous video, I ended it early because I was complaining about how smooth writing was. It was inconsistent. Um, that was one of the things that got fixed. Fantastic. For a moment there, I went to write something and it didn't click. Egregious. Okay. The what's it called? The fat lazy cat sat on the bed. I don't know how I came up with that. The fat lazy cat sat on the bed. Okay. These are all going to be tokens. I just tried to write something and it didn't go. Guys, I really don't want to get upset. Lazy cat sat on the bed. See, like I fear that I'm finding out that, like, I don't know, that Claude like fixed it just by like shifting it. Is like, how long can I write before it freezes on me? Unfortunately, the goalpost has not been moved sufficiently far back. I still run into it, but this is still okay. This is still okay. This isn't actually world ending. So let's see. Index wise, I believe it is your most recent token is actually always going to be index 0. I don't think you, how do I say? You could write things as like this: 0, 1, 2, 3, 4, 5, 6, 7, or you could do 0, 1, 2, 3, 4, 5, 6, 7. Oh, and you know what? I don't know. Let's see. I guess it kind of depends on how you do your mask. Let's assume that we're going to do a um, diagonal left causal mask. Okay. This is index 0 to me. 1, 2. Oh my goodness. Please. I'm being bothered. Oh, this is great that we can zoom in. Oh, wait, did I just break things? I didn't break things by doing this? Oh, very lucky is that we're panning and zooming on the whole thing. We're not moving the image itself, even though it looks like that. Perfect. To go 0, 1, 2, 3. Again, I'm trying to write and it's not writing. 4, and I'm not even going to try. So 0 sees very little information in terms of how I want to write the indices. So that is actually this order. So it is option 1 is actually how we are indexing our words. And let's say that this is also, this is how we've tokenized things. So did I repeat any words? Yes, I did. And this is a good, this is a good time for a case. So we have the index in the sequence, but we don't have its index as a token. So let's say sequence and then toke. And then So token, we'll do 0 again, and we'll do, ooh, this is unfortunate. Okay. As an audience, just don't get confused. Because I know I'm not going to get confused because like I'm literally writing this, but technically you could get confused with the fact that I'm using very similar indices, but talking about completely different pieces of information. Like the sequence index and the token index are not the same, but writing 1, 2, 3, 4, 5, 6 is easy for me. So um, let's see, the 2, 3, 4, 5, 0, 6. And this says, these numbers have nothing in common. You know what I mean? I'm just choosing that 0 is both the first word in the sequence and the first token that we produce in our vocabulary. Um, and the notable thing is that, this is its token ID is the and the have the same thing. And then as an embedding, I feel like I'm wasting time is, you know, everybody has a vector representation. That's fine. I was doing this because I wanted to draw the data set. So let's move out of here a little bit and then let's say data set. Okay. And we're going to mind the fact, as we learned yesterday, that the sentence is in fact one data point. Hmm. Hmm. It's sufficient for my understanding as of now. This is not a hard rule. This is a decision that I'm making in terms of how our data is being processed, and that is because of my limited scope. We're going to say that a sentence is a data point. And how that's going to look is as we did last time, is these are our inputs and these are our outputs. Okay, so the fat lazy cat sat on the, and then fat lazy cat on the bed. Importantly, they're the same size. Um, our inputs and outputs because they're literally perfectly going to map. So our data set, again, this is one point in our data set. So as far as I'm concerned, we have 1 point, which unfortunately is also index 0. So index 0, and oh, so straight lines would be nice. I'm just using GoodNotes, which is amazing. But yeah, it'd be really nice if I could snap these into perfect lines. So this is index 0, and how do I want to draw this? I think I can fit it all in here. So this is in. Let's be better. Let's be more researchy. We're gonna do X and Y. This is X. This but oi. Let's see. Y, X. Okay. This is X and Y of our data set. And then according to, so we have text, okay? We have BPE, which broke everything into a token and also gave us our vocabulary. Fantastic. We have our sentence represented as indices of sequence. So like our sequence length is 8. Um, no, omit that. Um, and then these are the tokens that we learned from BPE. So like we can sort of like ding 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 ding. BPE gave us those tokens. Um, and how do I want to write this? The sequence in order is Yeah, yeah. It's 0, 1, 2, 3, 4, 5, 0. It is. Let's write it with a red. 0, 1, 2, 3, 4, 5, 0. And then our output is 1, 2, 3, 4, 5, 0, 6. 1, 2, 3. Come on. 1, 2, 3, 4, 5, 6. Wait, what? Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 0, 6. Interesting. Okay. And that is, yeah, that's important. Is so yes, I'm actually not wasting my time right now. Is oh, I can't zoom any further out than this. I can only go zoom in. That's unfortunate. Okay. Oh, so I apologize in advance, or it's not in advance because it may be after the fact. Um, if I was writing anything down here and you couldn't see it, that is because on my screen I can see it still. Um, for my iPad. So again, that might be something I need to fix. Is like you can't see the numbers anymore, but I can. So I was totally like, using that as I was writing. Um, but yeah, no. Things should be fine. Um, what's next? Yes, so we have our data set. I really like this representation. We're actually, I do like this walkthrough. I don't think it's a complete waste of time. Is we have text, we've done BPE, and we have our data set. So this is the text of the internet. Let's see. Ding. Can I draw the World Wide Web? Ding, 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 ding. Nice. I'll take that. So that's the World Wide Web, and we're getting all of our text from it. And um, what's it called? That's our text. We tokenize it. Um, we get our vocab space, every ID for our potential tokens. So like the size of our vocabulary, again, I don't know how much value this is, but like this is correct information is vocab size equals um 6, 7, 7. Size of our vocab is 7. So there's 7 unique tokens in our vocabulary because this is all of the internet. Let's go with that. Um, so this piece of text is all of the internet, and it produces a single data point in terms of Carl's version of training an LLM. Whew. Um, so now we have a data set. We have we have a single data point. Um, we're going to load that into our model, and dot 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 is we must have configured our model. Let's draw an imaginary config. Is no, because I don't know how many unique, let's say n heads. Oops. We're gonna say n heads is the number of heads of attention, and I'm gonna go with 5. I don't know what number to use. We're gonna say nt is our number of transformers. I saw in GPT-2 it's 8. So we're gonna go with 8. How are we gonna handle position? I don't like that we're using equal signs. These are defined things. P, what was I writing? Position? Come on, post. Position is we're using rope. What are the other things that can separate our normalizer? Norm is both pre, it's post. I don't know. Let's say we're doing post norm. We're doing post norm and we're doing um root mean squared normalization. Sure. What else am I missing? Ooh, batch size? Batch size it has to be one for our sake. So we're doing pure stochastic gradient descent. Um let's see. Oh, D model. D model is a particular thing that must be decided on its own. Interesting. Oh, D model and every other, what's it called? Let's just say FFN. FFN. I'm just gonna draw it like this. We're gonna do a, let's see. We're gonna do an explosion and then we're gonna pyramid, you know? I don't know. Let's say, let's do big N subscript FFN, um, 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 parameters. No, parameters isn't enough. I need dimensions. Uh-oh. We're gonna go with the drawing. Is our feed-forward neural networks look like that? And they're all the same. So like, what's it called? You could totally have different transformers at different stages. Like they can have different sized feed-forward neural networks. Mm. For our case, they're all the same. Um, Architecture, multi-headed attention, dense. Let's see. We're not doing MOE. I don't believe in MOE. Um, Dense model. True. Okay. Are we missing anything else? Stochastic gradient descent architecture, which collapses D model. Um, nope. I think we have our config. We've got all the text from the internet. We tokenize it. We have our data set. Whew. Okay. Our data loader is going to take our data set and is going to point it towards our model as part of our loop. I say data loader. Data loader is like a thing in my head because I've never built one. Like I don't use it in class or anything like that. But I know it's necessary. Um, yeah, I feel like I hope it's a very simple role and that I'm overcomplicating it, that there's anything to think about it, other than the fact that it's the sampler for SGD. Other than that, I'm not really sure what else my data loader is doing. Is I have a big data set, and then the data loader is going to interact with the data set of what data are we going to pass to the model. Um, I don't even think it has anything to do after the backward pass. I think it's data loader, forward pass, backward pass, new data point, you know? And the data loader is just like, yeah, it's the most outside point of the loop. Is we're gonna loop, more data, loop, more data, loop, more data. And like, the data loader sort of manages, um, oh, oh, I don't know if I want to write this down, but for example, if you want to upweight, let's see, I kind of like that. If you want to upweight, so our data set, say it was more than a few sentences, we want to upweight our ability to do next token prediction on sentences that are about cats. Um, the data loader, despite the fact that our data set is like is discrete, our data loader allows us to sample with stochastic gradient descent at a different distribution. We can upweight the frequency at which we pull particular data points, and the data loader is the the bodyguard that determines what data the model sees. I think that might be the significance of it beyond just general input. You know what I mean? It's not simple. It's like what how do you want to load the data into the model? I'm okay with that for now. Um what else? Okay, but then it goes into the model. And I feel like doing the forward pass is not that complicated. Like at the end of the last video, I said it all out loud, and like I think I got it. Okay, I said it all out loud, but you need to write it down. So we would say data set, and then it goes into the model now. So what's it called? Now we're going to focus. So our data loader. So um yeah. So what I'm imagining is like we've done is if we're going top down, if I were to sort of redraw this, I don't have the ability to copy things. I wish I did. Um, is we've done, very step 0 is have text. Step 1 is tokenize it. Now we have a data set. And then now that we have a data set, we're going to put it into the model, which means these tokens are going to be embedded. So now, but we're also only going to care about X. So we have X and it doesn't turn into a perfect line. We have X and this is our first. Oh, I would be so happy. Yes. I'm actually cooking. Let's see. Data loader. And now that we've put it into the data loader, X, the only thing we care about, because we won't care about Y until we perform loss, is a D model by sequence length um, matrix, which is the input we've been talking about this whole time. So we are consistent so far. How do I want to draw this? This is where sort of our matrices are becoming far more important. No. Oh wait, that's fine. It's a batch. Yeah, it's batch size by sequence length. Yeah. So our first data point, actually. So the data loader selected this data point, which is a batch size of 1 by sequence length 7. 6. 1, 2, 3, 4, 5, 6, 7. Batch length or batch size by sequence length. Yeah, 1 by 7. These are all, it's just a vector. Perfect. Um, and then, but because B is 1, if it's 1, it doesn't exist. So it's just a sequence length vector. Again, perfect. That's exactly what we have. If B was greater, then we would have a couple of these, and it would be our first matrix. And it would be, and so yeah, it's good that we're working with a batch size of 1 as well. Is we would have our first, this would already be a matrix, and then it would immediately become a tensor the second we try to put it into the model, and then I wouldn't be able to follow along. So, what's it called? How do I want to draw this? D model is 3. Oh, did I not define? What did I define D model as? This guy. I wrote D model and put nothing. In our case, we're going to say D model is 3. Okay. That's so silly. I like that. I like that I caught that. Okay. Let's see. So D model is 3. Um, and this is an exact mapping as well. So I am curious about this. Is so the first set of weights of your model is effectively a lookup table. Is what we're hoping out of this step one is to produce the new matrix. We're not going to get into the data structure algorithm stuff yet, but we can literally search. My trivial horrible solution is already quadratic time. Is we can first is like for every single token, and then for every single vocab word, get the embedding for that token, and then concatenate a matrix. What is weird for me about that is that it's not linear algebra. So is it literally a lookup table? We're still staging things. I would say lookup table. So it's almost like, what's it called? W1. We're gonna have to come up with a better naming convention. But say W1, our vocab space is 7. So I need to write a 7, and this is from our initialized model, is I need a 7x3 matrix that is the randomized embeddings for every single token. So 0, nope. So 1, 2, 3, 4, 5, 6, and yes, and that's hidden from you. Okay, so this is hard for me. I don't want to come up with 21 random numbers, but that I have to. Maybe they can seem random if I do it in a weird sequence. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, oops, 17, 18, 19, 20, 21. Okay. Yeah, I think you see what I did there is like counting to 21 easier, but like I also don't want it to look like there was structure in the embeddings for every single token. So now it's seemingly random. Um, what's it called? So now by performing our lookup with our initial weights, we now have our first tensor matrix, whatever, that is sequence length by D model. And that will be batch length by sequence length by D model, but it's 1 by 7 by 3. And it's going to be very similar to this. And we're just going to replace like 5 with 1, 7, 17. So at index 0 is a 0. And we're doing sequence length by D model. So sequence length by D model. Yes, it's literally this. Where did the arrow go? I could have swore there was an arrow. Okay. There we go. What's it called? Let's do, it's the same thing. I really wish I could do duplicates. 0, 1, 2, 3, 4, 5, 6. And then 0 at 0 is still 1, 7, 17. And yeah, I'm not going to waste my time on that. The only difference is the fact that, so for our inputs, it's 0, 1, 2, 3, 4, 5. It's literally all the same thing, except for the fact that it's 1, 7, 17 at 6. It's literally the same thing as this. And that's just because of my poor design choices. But that's fine. So now we have X. Our data is loaded. We've used W, we've used the lookup table. That's weird. That's weird. That's a little bit weird. Huh. No, I think it's okay. So what's it called? I don't know. I like to, yeah, like my naivete tells me that if it has to do with weights, it's got to be linear algebra. um, but I have a feeling it's just a lookup. Is like we'll have the weights, we'll do the lookup, and then we'll perform the operation with it. Is like our input for which operations are then done on is, yeah, it's a lookup table. Yeah, because it's still these numbers. Again, that's why it's a little bit weird, but it's okay. It's consistent. It's these numbers still 1717 that is going to be multiplied by other things. So it is like the first step for gradient descent. Like when we do chain rule and whatever. Um, and the only reason the lookup is weird is because we're constructing our input still. Um, yeah. So we have our input. We have X. Then what? Rope? I'm not writing that. D model is unfortunately not an even number in this case, so rope is impossible. Um, so we would do rope, and then we would do attention. We'd put it into an FFN. The dimensions. Do we ever reach a tensor? I think this is interesting. This is interestingly something that like could be a coding exercise for me. In terms of what I can do from scratch, this is totally something that you can do in NumPy. Um, is Yep, we have that. We do our lookup table. We do we have our input. We're going to do all of that. We're going to pass through the transformer 8 times, purely matrix operations, and then we're going to take our loss and perform backpropagation, which is completely fine because it's just like normal. This is just all we do is put it into a transformer. Um, I do think, yeah, I'm no longer intrigued by the forward pass. I think we've done good. I think this is sufficient. I think I've drawn it out in like a little more detail, and I've just showed off that I have a new drawing skills. Um, yeah. Hmm. Yeah, so I think the next video is backprop. I'm happy with calling it here. I don't think there's anything interesting. We went through the transformer so many times. It's like what we've done is like the stages before that. Um, I've written out, QKV, blah 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 enough times. Like I'm pretty sure it's just math. Like attention is just math. It's a mechanism. That's fine. And then feed forward neural network. Can you write a neural network? Yeah, like whatever. Again, it's still just math. Um, yeah, like multiply matrices, hidden layers, activations. It's so boring. Um, FFN, and then yeah, as long as our dimensions line up, everything's fine. We can pass it through a few more transformers. Um, we could do concatenating and splitting on into whatever when we're doing attention to make it multi-headed. Not too interesting. Um, but backpropagation is interesting. For example, for me, how do you backpropagate multi multi-headed attention? I don't know. So backprop, a step of backpropagation. I think that's something. Um, yeah, I think that's something because the autograph, the autograd graph, um, I'm very curious what it looks like given the actual mechanisms that are being used. For example, do you need to do backprop on rope? And how would you do back prop when you were doing? How do you do back prop for an RNN if it's being additive? Very curious, very curious. So back propagation is next. I think today is just a good exercise, good video. Um, we locked in. Let's see if there's anything. I don't know. Is there anything cool? Whoa, where did I go? Is there anything cool I can do? Is there any like um thumbnail? Why do I keep disappearing? iPad is still connected. Let's see. That's weird. Um, oops. Yeah, I think today was good. I think next video we try to do back prop because I have no idea where to start for that. Um, this showed some things, good information, good exercise, good consistency. Um, fantastic. What are we missing? Nope. Yeah, I need to start coding. Maybe I should like read the code of NanoGPT, or maybe I should read the model.py from our professor again. See if it see if it makes any more sense now. I think it made sense before. I read it before. Um, but maybe it's a bit more coherent now that I've continued to revisit what's going on here. Um, I want to do a cool. Let's see if I have any cool photos. Let's see. What should the thumbnail be? Wait. Wait, I have an idea. Wait. Oh my goodness, it's so stupid. Wait. How do I do this? How do I do this? Um, wait. Okay, you can't see that anymore. Delete, and then I'm gonna save this. I'm gonna save as, and what's today's date? 7/25. Save as. Board name 7/25. Okay. New board. Okay. What's it called? I don't think you're supposed to see me make my clickbait, but whatever. Okay. This would be so cool if it works. How do I get the babies to fit though? Photo library. It would, yeah, the babies would have to fit perfectly. So yeah, I'm the middle ground. I think this is possible. Guys. Oh wait, it's here, it's here. I have to do it here. Okay. Yo. Yes. Okay. Okay. Um, that could totally be like so embarrassing for me. This guy just did a YouTube thumbnail. Um, okay, yeah. I'm trying to have fun with this. Um, so that's it for today. Tomorrow we're gonna try to do back prop and video.